Okay, this is how to do homework 1.2 question number 9. I'm going to skip over some parts of this, namely part A. Part A is just asking you to see if this point is on the graph, and I have an entire video dedicated to that, which you can find in the top right corner of this video. For part B is asking you to replace x by -1. So instead of x, I'm going to swap out every time I see an x, replace it by -1. So I'm going to have 3 instead of x squared, it's going to be -1 squared. Instead of minus x, it's going to be minus -1, and then minus 2. So just watch your negatives when you simplify this. -1 times -1 is +1. Negative times the -1 is +1, and then minus 2. So it looks like so this is going to end up being 3 plus 1 minus 2. In other words, 4 minus 2, that gives me the value 2. So it looks like when I plug in -1, it spits out 2. So my point would be written as -1, 2. Input, comma, output. Okay? This next part C over here, is saying if I know my output, what did I plug in? So this is kind of taking part B and spinning it on its head. It's saying instead of plugging in an x and simplifying, instead I need to swap out my y and solve for x. So I'm going to have -2 is equal to 3x squared minus x minus 2. And this needs to be solved for x. So the first thing I'm going to do is make this equal to 0. And the way that I do that is by adding 2 to both sides. So I'm going to have 0 equals 3x squared minus x, because I'd basically do +2 and +2. So just to be clear, +2, that cancels this out, +2, that cancels this out. And at this point, this is factorable. You could also use the quadratic formula to find this, but what I'm going to do is factor out anything in common between these two terms. And it looks like they each share an x, so what I'm going to do is I'm going to pull out an x to the front, and what's going to be left behind in this parentheses is whatever I have after I divide by x. Sometimes you see that people do this in their head and they don't bother to write this step out, but this is exactly what I'm doing. Okay, so just to simplify the inside of the parentheses, x squared divided by x, well, that's just going to leave me with one copy of x. X divided by x is 1, because anything divided by itself is 1. Okay, so this is my factored form. The way that I can check to see if I've done my factoring correctly is by multiplying this back together and seeing that I get what I started with. X times 3x does give me 3x squared. X times -1 does give me -x, so I've done this correctly. Now the reason I did this is because I want to use something called the zero product rule. The zero product rule says that if I have something like A times B, if I have two things that are multiplied together, and I know that they give me 0, then either A is equal to 0 or B is equal to 0, or potentially both. They could both be 0. But the idea is if I know that my two things multiplied together give me 0, well then one of these guys definitely had to be 0. So that's what we're going to use here. I have this you could think of as my A. So I'm going to go ahead and highlight this red so that way they match. And I can think of this guy, I'm going to make it blue. This guy is kind of like my B. So to get my answers for X, I like to put mine in curly braces, but you don't have to do that. This is just my own personal quirk. I have this guy is either equal to 0 or this guy is equal to 0. And at this point, I can now solve for X. The first guy, my red one, is already basically solved. I don't need to do anything. X equals 0, it's already solved. On the second guy, I want to do +1 to both sides. And my next step, I would have to divide both sides by 3. So I get x is equal to 1/3. So these would be my two answers for when f of one of these two is going to give me -2. So in other words, when I plug in 0 or 1/3 for x, it's supposed to spit out -2. That's what I've just found here. Okay. So for the next part, I would say, what is the domain of f? Again, I'm going to reference the 3-step process that I talked about during lecture, where first off, I'm going to start with all real numbers. I'm going to say, all right, my domain is going to be everything first off. Now I want to ask myself, do I have a fraction bar? Are there going to be any x's in the denominator? Nope, don't see any x's in the denominator. So I don't have any errors to worry about there. Next up, I'm going to ask myself, are there any square roots? Also no, there's no square roots. So nothing there is going to throw me an error either. So my domain is going to stay all real numbers. In other words, I can plug in whatever I want for x, and it's not going to break the calculator. I'm always going to get something out. So my domain is going to be all real numbers because I don't have any errors from fractions or square roots. Just to mention later on, we're going to get more things to potentially worry about causing errors, but for right now, this is good enough. Oopsie, don't do that. Okay, for part E, it says list the x-intercepts, if any, of the graph. So finding an x-intercept is the same thing as setting the function equal to 0 and seeing what I get for y. So here's my function. I'm gonna move this over here. I'm setting it equal to 0, and now I need to solve for x. I'm sorry, I think I said solve for y. Set my y equal to 0, solve for x. Now the problem is, how do you solve this? We haven't covered ways to actually deal with this, so I'm going to give you two different ways. Method number one, actually I'll say method number one, quadratic formula. And we're going to talk more about these as well. So actually real quick, I'm going to insert a table and separate these two. So method number one is quadratic formula. Method two is factoring using the AC method, which is a different factoring process than what we did before. But the idea behind this factoring is the same. I can figure out what my x's are by essentially using the zero product rule. And in order to do that, I need to factor, except the way that I factor in this case is different from the way that I factored up here. Up here, I got lucky because this piece had an x in it and this piece had an x in it, so I was able to pull out an x. However, I have to find something that's in common between all three of these pieces, and they don't share anything. These two pieces have an x in them, but not the third guy, right? They don't even share any coefficients in common. So there's not really a way for me to do this on, or not really a way for me to factor the same way that I factored up here. I have to use a different method. So the quadratic formula, eventually you'll know this, eventually you'll memorize this, but for right now, the quadratic formula tells me that my two x answers, x1 and x2, so my two answers, it's going to be given by -b plus or minus square root b squared minus 4ac all over 2a, where, so if my function is given as a quadratic, it's ax squared plus bx plus c. So essentially, these a, b, c's are the coefficients that are in front of x squared, x, and the constant. So just to illustrate where they're coming from, this right here, I've already used red. I'm going to use different colors now. So I'm going to use orange. This guy's going to be green over here. And this guy, I guess I'll just make it, we'll grab a pink. Why not? All right. And just to color code them in the formula as well, here's a C. Here are my A's. And here are my B's. Boom, boom. So let's take a look at what we have. Let's compare it to, oopsie, I don't want to ruin that. So this is what I've got. Want to make sure that's lined up as best I can. When it says minus x right here, that's the same thing as saying minus 1x. right? And another way to say that would be plus a negative 1x. That's just another way to rewrite what I've got here. Now, it seems a little silly for me to do that, but the reason why I'm doing that is to make it clear which numbers correspond to A, which numbers correspond to B, and which numbers correspond to C. So this one's going to be my A value. A is the number in front of x squared. Boom, that's 3. B is the number in front of x. The number in front of x is negative 1. And C is the number that gets tacked onto the end. That's going to be negative 2. So everywhere I see a green B, I'm going to replace it by negative 1. Be very careful when you do this. It is incredibly easy to lose a negative and simplify this wrong. Everywhere I see an A, it should instead be replaced by a 3. And everywhere I see a C, it should instead be replaced by, instead be replaced by negative 2. So all the pieces line up now. Now I very carefully have to simplify this to get a number out of it. So negative 1 squared is 1. 4 times 3 is 12. Times 2 is going to be negative 24. 2 times 3 is 6. In the front here, I have negative negative 1. The negatives cancel to give me positive 1. So again, I'm going to keep going. Negative negative is really plus. Okay. 1 plus 24 is going to be 25. All right. Finally, square root of 25 is 5. So my two answers, this plus and minus symbol that's in the middle basically splits this between a positive answer and a negative answer. So like using the positive version. So one of my answers is going to be 1 plus 5 over 6. And my other answer is going to be 1 minus 5 over 6. So again, I'm going to keep simplifying. Real quick, I'm going to separate these two a little more. 1 plus 5 is 6. And then 6 over 6 is 1. 1 minus 5 is negative 4. Negative 4 over 6, that fraction simplifies to be negative 2/3. So this is how to find my two answers using the quadratic formula. And you're going to get a lot of practice using this. So if that seemed weird or it seemed confusing, don't worry, you'll get better at this later. Okay, factoring using the AC method. So unfortunately, this suffers from a similar issue where we haven't even learned factoring yet, and this is this very specific type of factoring. However, I did not make the curriculum, so it just kind of has to be what it is. The first thing I'm going to do, the reason why they call this the AC method, is I'm going to take my A value. So remember, my A is this guy right here, and my C value, which is essentially this guy right here, needs a plus. I'm going to take my A and my C and multiply them together, and that's going to be the new number that goes to the end. The way that I think about this is I'm literally going to grab this number and multiply it to this, and it's going to stay there. So instead, I'm going to try to factor. I'm going to move this 3 over here and multiply those two. So in other words, this is going to be 2 times negative 2 times 3. That's going to be a minus 6. And now I want to factor this. So this is an easier method of factoring that you may or may not know already. To factor this, I need to come up with numbers that multiply to negative 6, but add to negative 1. So this number right here, I'm going to use different colors for this now. So I'm going to make this blue. And the reason why I have this negative 1 is because of this guy over here. So, and I already used green. Let's see. Yeah, we'll go back to red. So I need to come up with numbers that multiply to negative 6 and numbers that add to negative 1. And it comes from basically those two. So usually we start with numbers that multiply to negative 6. So my options are 1 and negative 6. So 1 comma negative 6. Or I could flip the negatives. So I could have negative 1, positive 6. or I could have -2, +3. Or I could keep or move the negative basically. So I could have 2 and -3. So this is one set, this is another set, and I believe that's it. That's all I've got that adds up or that multiplies to 6. So now I need to come up with the pair that adds to the correct number. So this right here, this is going to add to -5, so I don't want that. This is going to also add to 5. This is going to be a +5. Over here, this is going to add to 1. Hey, this is my 1. This adds to -1. So this is the pair that I want. I want these numbers right here. Okay, so in normal factoring, you would kind of just be done, but with the AC method, I'm not done anymore. I needed this pair of numbers. What this is going to do is I'm going to go back to my original equation, and I'm going to split up this -x into +2x minus 3x. So this is going to be +2x minus 3x. So just to be clear, I started with this, and what I'm doing now is I'm taking this highlighted yellow guy and I'm splitting it up according to the magic numbers. Okay, now it doesn't seem clear on like why I did that. And you could even put this, actually better yet, I'm going to change the order. It doesn't matter what order you do this in, it's going to work out either way. But now I want to work with this. So this guy, I want to factor by grouping. So at this point, I'm going to remove the color coding and the highlight and instead focus on doing factor by grouping. Okay, again, another factoring technique that we haven't necessarily gotten experience with, but we will in the future. So I think probably the easier method for doing this is with the quadratic formula. All right, so by factor by grouping works by artificially clumping together pairs of terms. So I artificially grouped together these first terms. Oh, that's a way too bright. I don't want to use that. Yeah. So I'm going to artificially clump together. We'll use dark blue and dark red. Why not? So I grouped them together. All I did was I put parentheses around them to clump them. Those are my groups in quotes. And now what I want to do is factor out as much as possible from each group. So I'm noticing that on this blue guy, this piece shares 3 and x with this piece. So I'm going to pull out a 3x to the front. And then in here, I have to divide by 3x on each piece. So I'm pulling out a 3x. I'm going to make this dark blue. Over here, I'm noticing that both pieces have a 2. So I'm going to take a 2 and I'm going to pull out a 2 here. And I have to divide each piece by 2 as well to see what's left behind. A lot of the times people won't write this step. They'll simply skip this step and write the result. So don't be surprised if you look this up and you don't see this step anywhere. 3 divided by 3 cancels out over here. X divided by x cancels out, so I'm just left with 1 copy of x. 3x divided by 3x is 1. Over here, 2 divided by 2 is 1, so that leaves me with just an x. And now I have 2 divided by 2 is 1 again, but it's going to have to be -1 because of the minus. So to spare myself, I'm going to rewrite this as -1. Okay, we're almost done. Next up, I know I've done factor by grouping correct if these parentheses right here, if these parentheses come out the same, which they did, that means I've done it correctly. What I'm going to do is now I notice that this piece and this piece shares this x minus 1 in common. So this x minus 1 is going to come out to the front. I'm basically going to factor this parentheses out. So this is going to come out to the front. Better yet, I'll write it the same way that I've been writing it. Here's my piece that comes out to the front, and what's left behind, I have to divide by x minus 1 on each piece. This looks horrible, but it's actually not, because basically the x minus 1s cancel. So x minus 1 is gone, x minus 1 is gone, just leaves me with 3x. These things cancel and just leaves me with 2. So I know it looked horrible. I'm going to get rid of the highlighting. on this. But I'm basically doing the same process that I did up here. Again, a lot of people just skip that and jump straight to this result. Now I don't need the color coding anymore. So at this point, now I could say solve using the zero product rule. So what I have, again, I like to put them in little curly braces, but you don't have to do that. I have this guy could be 0, or this guy could be 0. And now I just need to solve each piece. So for my first guy, my top equation, all I need to do is +1 to both sides, and I'm done. For the second equation, I'm going to subtract 2. And next up, I need to divide by 3 to get x by itself. So these would be my two answers by factoring, solving by factoring. And you'll notice, actually, I'm going to use a different highlight because I already used yellow. This is my answer. This is my answer. I got the same answer using 2 different ways, except this one was a lot more work, especially because we have not done this yet in lecture. We'll be doing this, I believe, 2 lectures from now. So I know this is probably the way that they intended for you to do this. Alternatively, it is possible to do this on a graphing calculator. The points are actually right there for you. So real quick, I'm gonna open up Desmos. Here is my function, which was y equals, let's see, 3x squared minus x minus 2. And I'm going to go ahead and make this a little easier to see. So Desmos is very nice, and it pulls these points for you. And we can see that I do get the same answers of 1 and negative 2/3 because negative 0.66666 is 2/3. My answer is on a graph as well because negative 2/3 is actually equal to negative 0.66666 forever. The only catch is if you looked at a graph first, you may not know that this is supposed to be negative 2/3. So that's the downside to graphing and finding the answer by a graph. Okay, so that was a long part. But finally, it says list the y-intercept if there is one. The y-intercept is thankfully much easier. The y-intercept is instead making x equal to 0. So before we made y equal to 0, and that was a huge pain. But now all I need to do is take my 0 and plug it in for x. So this is going to be 0 squared. This is going to be minus 0. So in the end, I'm just going to get 0 minus 0 minus 2, which is negative 2. Right, because this is just 0. This is already 0. So the only thing I'm left with is negative 2. So my y-intercept is going to be negative 2. So this is how you tackle a particularly nasty problem from homework 2.